You are the sky, everything else, it's just the weather. Good afternoon, everyone. I am Sai Madhuri, Creative Volunteer, hosting 154th episode of Creative Weekend Talks. Creative is a group of people gathered together to gain and share their knowledge. Hence, our tagline is Knowledge Square because sharing knowledge doubles it. Vision of Creative is to build a constructive thinking on various domains. And our weekend talks will be live streamed on the YouTube channel Creative GBD. Today's World Space Week 2024 special talk series is on climate variability and early warning of extreme events. To discuss this topic, we have an speaker, Mr. Anand Sharma, President Indian Meteorological Society and former additional DG Scientist G IMD New Delhi. We have Kumari Raghavi, creative volunteer, to introduce our today's speaker with us. Over to Raghavi.
Good afternoon. My name is Raghavi, studying in 8th grade. It is my great privilege and honor to introduce our distinguished guest today, Sri Anand Sharma, a visionary in the field of meteorology and environmental sciences. Sri Sharma has an illustrious career spanning decades of exemplary service to the nation in various capacities within the India Meteorological Department (IMD), where he has served as a scientist G, head of the Regional Meteorological Center in New Delhi, and additional Director General. His leadership and expertise have been pivotal in various meteorological initiatives across the country. Sri Sharma's academic background is equally impressive, holding an MPhil in Environmental Sciences from Jawaharlal Nehru University, Delhi, and MSc in Agriculture Meteorology from Punjab Agricultural University, and a BSc Hons from the University of Delhi. His deep knowledge and passion for environmental science and meteorology have earned him several prestigious awards and fellowships, including the National Scholarship, Gate Fellowship, and UNDP or WMO Fellowship. Over the years, Sri Sharma has made remarkable contributions to critical areas such as weather prediction, crop weather simulation, agro advisories, mountain meteorology, disaster management, and early warning systems. For extreme weather phenomena, he is a true pioneer in environmental security and awareness. Having been trained in the USA, France, and India in advanced weather forecasting techniques, his, his professional journey has seen him serve in key IMD locations including Pune, Bangalore, Gangtok, Dehradun, and New Delhi. Sri Sharma's leadership is most noted for his time as founder director of the Meteorological Center in Dehradun, where he served from 2002 to 2015. His work is his work in early warning systems and extreme weather forecasting has saved countless lives and minimized damage from natural disasters. One of his most celebrated predictions was the accurate forecast of the Kedarnath heavy rainfall event in 2013, a prediction that brought global recognition to his work. He has also led several important projects, including the Approbe project, which established 100 observatories in Uttarakhand schools and a World Bank funded early warning system for hydrometeorological events in the region. In addition to his scientific contributions, Sri Sharma is a prolific educator and communicator. He has published over 30 scientific papers and a book on the climatology Dehradun, and his work has been recognized with numerous awards such as the Mohs Award for Excellence in Atmospheric Science, HUDCO Award for the Best Practices in Early Warning, and Doon Rathan and Uttarakhand Rathan Awards. His extensive media presence includes over 12,000 interviews across radio, television, and print, bringing meteorology closer to the public. Sri Sharma is also a respected figure in the academic world, serving as a visiting faculty member at several prestigious institutions, including the National Academy of Administration in Mussoorie, JNU New Delhi, Jamia Millia Islamia and Aligarh Muslim University. His contribution to national and international projects had his ability to communicate complex scientific concepts to the public and are widely respected. Please join me in welcoming Sri Anand Sir. Thank you.
Hello.
Thank you, Raghavi. It's a pleasure to have you with us now today, sir. Now the talk will be started. Over to Anand Sharma, sir.
Namaskar and a very good afternoon to all of you. Can you hear me?
Yes, sir, you are audible.
Wonderful. So thank you very much to the entire team for giving me the opportunity to interact with all of you. And I'm really impressed by Raghavi. I think she is in 8th standard. That's right.
Yes, sir. Yes, sir.
Very nice. Thank you, Raghavi, for introducing me. And very good. At that age, I never had that confidence to speak like this. So very
Thank you,
nice.
sir.
All the best and God bless you. Okay. So now
Thank
the
you, sir.
topic of today is, climate variability and extreme events. But before I start with the lecture, I feel, because all of you must be new to this subject. So I will start with very basics first. Okay. Because we have to explain what is climate variability, and you also heard about climate change, and then those climate change leading to different kinds of impacts, which have, implications to us, and they may, make our life difficult. So before that, so I will begin with first things, what is weather and climate. First, we need to know between these two things, what is weather and what is climate. So like you must have heard, weather is, like instantaneous state of atmosphere. When I say instantaneous state of atmosphere, it means right now what is there outside. Like if you in your area, if it could be cloudy, it could be sunny, or maybe windy, if wind is strong, or if clouds are very deep and multi-layered, maybe you are getting rain. So it depends what kind of situation is. So instantaneous state of atmosphere with respect to temperature, humidity, wind, rainfall, etc. is known as weather. And what is climate? When you sum up the weather over a place, over a period of time, that is average, we call it climate. Like, for example, if you average it over a 30 years period, then average weather, it becomes climate. Or if I have to explain it in simple terms, weather is like your watch. When you have a watch, you see seconds needle. It keeps on changing. It keeps on moving fast. So it is changing. The weather is also changing. Morning, you must have seen morning, it is sunny when the sun comes out. It's a little cool, but when the sun comes out in the daytime, it's very hot. And again, evening when the sun sets, again, the cooling starts. So it keeps on changing. Okay. So that is why we say, weather, if you don't like weather, wait, it will change. Fine. So weather is like your seconds needle of the watch keeps on changing. And your climate is like calendar, where you have monthly calendar. It's a sort of average. This is one thing. Second, another thing, you must have also heard about the word mood. Often you heard people saying, my mood is not okay. Or he's in angry mood. Or he's in jolly mood. So weather is like your mood. And climate is your personality. Is it okay? So this is how you can differentiate between these two. And now, from now onwards, we will move to another concept about normal, below normal, above normal, and abnormal. It could be temperature, it could be rain, or it could be wind, any of the weather parameters. So when I say normal, say for example, when I say normal maximum temperature of today over Delhi, say hypothetical case, what does I mean by normal maximum temperature of the day? So what I do is I take the maximum temperature of today, that means 21st of September, for the last 30 years, and I add those values and divide it by 30, I will get one figure. Say, for example, hypothetical, I get a figure of something like 31 degrees. That says it is the average or normal temperature for 21st of September for Delhi. But when in the evening around 5:30 we note the maximum temperature, it could be 31, it could be less than 31, and it could be more than 31, or it could be something much more than that as well, possible. So 31 is the normal. But suppose in the evening I recorded 28, maybe there is some cloudiness there, and so temperature may not reach 31, so it is 28. Or say, uh, after some time, it becomes very sunny, it's very hot, or the temperature is something like 34 degrees or 35 degrees. So what do you call this? Now, 31 degrees was your normal maximum temperature for today. But what you recorded, if you recorded below 31, you call it below normal temperature. And if you record, say, 35 degrees, which is more than 31, you call it above normal temperature. So this is the difference between below normal, above normal, and normal. Okay. Now what you do is, suppose you have 100 years data of your station. Say again, Delhi. And if I see past 100 years data, I might see, the temperature even has maybe varied between something like normal 31, but it has varied from something like 24 to 37, 38. So this is called natural climate variability. Okay. But all of a sudden, you see in the last 100 years, the temperatures, either it was 24 degrees or it was 37 degrees. But suddenly you record a temperature of 40, 41 degrees on 21st of September, which has never happened in the past 100 years of history. Then what will you call it? You will call it abnormal. So now I think everyone understood what is normal, what is below normal, what is above normal, and what is abnormal. So this abnormal temperature is something which people are talking about these days. That is something which has not happened in the past and now it's happening. It is extreme. So that kind of thing comes under climate change. So now with these two concepts, I go back to the topic. So like all of you know, Earth's climate has never ever been constant. It has been changing and leading to often wide range of variations and changes in space and time. Okay, so naturally it changes, and there are a lot of these variations are in space as well as time, and often leading to extremes of weather. And this is its fundamental characteristics. So extremes are possible because of natural interannual climate variability. That means nature, because of natural reasons, climate varies and often leading to extremes. That means when we say extremes of temperature, extremes of rainfall, extremes of winds, extremes of cyclones, everything comes under that. So remember that, say 100 years back also, when there was no talk about greenhouse gases, pollution, all these things, global warming, still extreme weather was happening. There were floods, there were extremes of rainfall, snowfall, landslides, you name the thing, everything was there. But now, because of human activity, which we call it anthropogenic activities, that means due to human activity, because we all know our population is increasing and we have to feed, huge population. We have to feed them, we have to provide them basic facilities, and population is continuously increasing. And to provide those basic facilities like food, housing, transport, clothes, everything. So when we tend to provide those facilities to the people, we have to put factories, we have to have industries. And by doing that, what we do is that we also pump gases, which we know it as greenhouse gases like carbon dioxide, nitrogen oxides, methane, Even water vapor is a greenhouse gas. So these gases, which we call as greenhouse gases, they have a property that they what they do is, normally what happens is the radiation comes from the sun, which we call as insolation, incoming solar radiation. It has both short wave as well as long component, but short wave component is more. So when the radiation comes, it hits, strikes the ground, a part of it is absorbed, and then it is retransmitted back. So when this radiation is going back, what happens is it goes to the space. But there's these gases, which I told just now, greenhouse gases, has a property to absorb this outgoing terrestrial radiation, that the radiation which is going back from the Earth. So when the radiation is absorbed, it leads to rise in temperature of the Earth's atmosphere, which we know as global warming. So now some people feel that means greenhouse gases are bad for us. But yes, they are bad also, they are good as well. If you remove all the greenhouse gases from the atmosphere, Earth's atmosphere, so most of the radiation will go back, and Earth's average temperature will touch something like minus 20 degrees or even lesser. So most of the places life will become inhabitable. So it is a right mix of greenhouse gases which makes the Earth habitable place. Okay, but then what is happening is, due to increased pumping of greenhouse gases by the humans into the atmosphere, the concentration of greenhouse gases is increasing, and that is absorbing more and more outgoing radiation, long wave radiation, leading to rise in temperature of the Earth's atmosphere. And our data shows that for the past 100 years, almost there is on average, there is a warming of 1 degree Celsius over the globe, which we know it as global warming. And even India data is also showing something like 0.7 degrees Celsius rise in temperature for the past 100 years. So now scientists are saying, if we keep on pumping greenhouse gases at this rate, which we could know as business as usual phenomena, and this is going to lead to increase in the frequency and intensity of extreme weather events. That means there will be more extreme weather events in the future, and also their intensity will be more. Suppose there used to be some 20 centimeter rainfall earlier, maybe that area might start getting 30, 30, 35 centimeters of rainfall. Suppose there used to be a cyclone earlier in a particular region, it could be severe cyclone or a very severe or extremely severe cyclone. So that is what they're saying. Or the number can also increase. Okay. How? Okay. Just a minute here. Are you getting this thing? If anybody has having any confusion in it, any confusion anywhere?
No, sir. It's
No.
clear.
Fine. Very nice. Very nice. Okay. And people can jot down questions if they have. So then we will have a lot of time to discuss those issues if somebody has a confusion. Fine. So as I said, and scientists are also saying, using your numerical weather prediction, that you know that these days we make use of computer software and supercomputers and whatever observation we collect all over the globe, and all those things goes into the computer, and then we predict the weather. And when you run the climate models, it says that by the year 2100, the temperature might go up by 4 to 6 degrees above normal. That means whatever we are observing now, like as I say, 100 years, there's increase in 1 degrees. But by the 2100, the temperatures might increase by 4 to 6 degrees, depending on different models have different projections. But yes, there is a trend, global trend, saying that there will be increase in temperature as we go towards 2100. So that means, if that happens, it means in future, climate risk is going to increase. So what they are saying is climate risk. Because of climate, the risk will increase because there will be more extreme events. And naturally, if that happens, the people who are vulnerable, because there are certain people who live near the flood, who have constructed their houses in the floodplains near the river, or who live near the sea, or they live in the mountains, such regions which are landslide prone. So all those areas which are vulnerable and where people are living, their climate risk will increase. Already, some of the, and again, scientists are also saying, already some of the things which like extreme weather, they are happening over India, all over the world, in fact. But if you see, but there is no uniform pattern all over. In certain pockets in India as well, they're saying, look, there is increase in temperature as well as indications of increase in extreme weather. But somewhere even reverse is there, and somewhere no change. So, but yes, signals are there, and people are definitely at risk. So, what we should do that? Now, question comes naturally with, and in future we are pumping more and more greenhouse gases, that we call it business as usual scenario. If we don't change ourselves and we keep on pumping greenhouse gases at this rate, so definitely temperatures will increase. Your extreme events in intensity as well as frequency will increase, which will lead to increase in climate risk. That will more people will be under climate risk. That means they will have problems. Maybe there will be loss of life as well as property. So our aim here is to make the societies resilient, right? When I say the word resilient, it means we should make society such that either, I mean, like uh, they get the climate predictions and weather forecasts well on time. And this weather forecast should be timely, accurate, and it should be impact based, actionable, and it should be in simple language. So I have used several words. When we say weather forecast, the most important, there are certain attributes of a good weather forecast or warning, or which we call it early warning. So there are certain attributes of that, any good forecast. What are the good, this thing? First thing, it should be timely. That means the weather forecast should reach the planners and the general masses well before the event. Okay, suppose a heavy rain is going to happen. If we communicate to the masses and to the planners, to the people, well, but say 2 to 3 days in advance. Look, after 48 to 72 hours, heavy to very heavy rain is going to happen. So it becomes a timely. Now, accurate. Accurate means it should be accuracy. It should happen. It should not happen like we say, heavy rain will happen and it doesn't happen. And every time you keep saying that, then people will lose faith in you. So it should be accurate, timely, accurate, and then location specific. That means you should clearly mention which area. Suppose you are like in Goribidnu, the weather should clear, the forecast and early warning should clearly say heavy rain likely in next 48 to 72 hours in the Goribidnu and surrounding areas, maybe 50 kilometers and all around, where the forecast and warning is applicable. So that is one. Fourthly, the language should be simple because you are in Goribidnu. It should be in Kannada because most people understand Kannada. So, but if they talk in English, maybe few people might understand, but not the general masses, the farmers, the rural area people. So the warning should be in the local dialect or local language over Kannada. Fine. And the forecast should be impact-based and actionable. What does it mean, impact-based forecast? It means that when I say heavy rain, not many people understand the meaning of heavy rain. It basically means around 7 centimeters of rainfall or 70 millimeters of rainfall. But again, people do not understand what does that mean. So we have to tell them, look, if this much of rain happens, it can lead to flooding in the low-lying areas, water accumulation can happen, or there may be certain pockets where, if there is no drainage, then the water level can rise, and then it can create problems. It can lead to traffic disruption, or if there is a thunderstorm which has led to this rain, and there are strong winds as well as, so it could also break certain, branches of the trees, or maybe if there is a squall, very strong winds for a few seconds, so it could even uproot the big trees. So all those things we have to communicate to the people so that they know what impact this early warning, which forecast has been issued, what impact it is going to create. And actionable, definitely the planners who have to act, they should understand what action they have to take. If it's an area where flooding can happen, they should immediately vacate. They should find out which are the most vulnerable population of that area, where flooding uh, can go, say, up to 1 meter or so. That means that is the most vulnerable area. That is people living in that area, they are the most at risk. So those are the people who should be removed first. Or maybe there are old people somewhere, or people who can't hear, how to communicate it to them. So these kind of things, are very important. If all these things are done, then definitely your forecast has value, and it has reached the user, and they have acted upon. And if they do that, then we can reduce the climate risk. So that means if you do all these things, and you have various authorities who have to take action, weather department and media, and if they're all in the same, I mean, frequency, then definitely you can save lives. And plus, you can also tell them what to do under such circumstances. If you do that and train them well, prepare them well, then you can make the society resilient. That means they know what actions to take. They can save their lives. But even suppose sometimes, because 100 forecast is never 100% accurate, so it can go also wrong. And but if a extreme weather or a hazard impacts them, then, and there are certain damages, they should bounce back better. They should bounce back fast. What has happened. Now they have learned lesson, so that in future they don't do it, and they rebuild and go back to the normal situation very fast. That is called resilient. Or in simple terms, if I have to explain the word resilience, it means, like suppose I give you two examples. There's a strong wind blowing, very strong wind, something like, say, 90 or 100 kilometers per hour. You have one big tree in that area, and you have some grass growing nearby. Which of these two is resilient? Often people think, tree, it's so huge and strong with strong stem, that must be the most resilient one. And grass is very thin, it can't be. No, but it's the grass which is resilient, because what happens when there are strong winds, the trees get uprooted. But what happens with the wind? When the wind is 100 kilometers, the grass just swings and gets back immediately. So that is called resilience. That means nothing happens to it, it bends, but then gets back. So that is what we have to make the societies resilient. Remember, climate change or no climate change. With climate variability itself, we will have extreme weather events, but due to anthropogenic pressure, the climate variability can further increase. That means we can expect more increased frequency and intensity of extreme weather events, exposing people to risk, and sometimes the hazard will get into disaster if not forecast well on time, or if not acted upon. Then in that case, society will be affected, people will be affected. But we have to, we have to prepare them in such a manner that even if there is a disaster happens, they should bounce back fast, and they should build back better. If they do that, then we can make society resilient. Now, from here, again, as I told you, this is about your climate variability, change, global warming, change, and then the extreme weather events. So, and different extreme weather events, I've already told, it could be heavy precipitation, rainfall, or heavy snowfall in mountains, or it could be thunderstorm, lightning, it could be squall with strong winds, it could be hailstorm, where you have this thing, ice balls which fall, and it could be even table tennis size or golf ball sometimes, and that would be very destructive, and within no time it destroys your crop, and maybe any other cars or anything others, structures, it could be destroyed. So these all extreme events are possible, and we have to be careful for that. But the good thing is that India Meteorological Department has an excellent forecasting system in place for many of the hazards. Of course, there are certain hazards which happen over a very short period of time. They hardly give you any time. And if you don't have specially radar system to monitor it, then it becomes difficult. But otherwise, like cyclone, for example, whenever it comes, any cyclone develops in the ocean, India Meteorological Department has an excellent system of monitoring it, tracking it, and then predicting its course, where it is going to hit the coast, and what kind of impact it will have. And because of that, earlier when 100 years back cyclone used to strike Indian coast, people used to die in thousands. But now the figure has come down to hardly less than 100 or less than 10, in fact, in some of the cyclones. So that's a very good achievement. Now, coming to early warning, as I said, we have to talk about the early warning system. So remember, this early warning system has, many people think that it is some kind of machine from which the early warning is generated. No, it is a system. That means it has four components. Early warning system has four components. And the first component is risk analysis. That means whichever area you are, either in Goribidnur or you are in Mumbai or you are in Bangalore or you are in Kerala, whichever city you are there. So you should know the risk in that particular city. If it is a coastal city, naturally you have a risk that a cyclone can come, water flooding can happen, water level can rise, trees uprooting can happen, all those kind of things. If you are in the mountains, maybe flash flood, where the flood comes very fast, or landslide can happen. So, or you are near the forest. If your house is near the forest, there could be forest fire. So different areas have different kinds of risk involved. So what is required is risk analysis, like in a particular district or taluk or city, which are the areas which are the most at where people are most at risk. So if you should have a risk mapping done in that area, normally it is done by the state governments, but some of the areas, like in the mountain regions, in fact, like ISRO has done landslide mapping of mountains, or GSI does that. And then Survey of India does, which are the areas where tsunami or sea level can rise when the tsunami comes. So different, but it is basically the state government. They should be doing the risk mapping of their particular area, where people, which are the areas where people are most at risk. So once that is done, the next component of the early warning system is monitoring and prediction of weather. And monitoring of prediction is mainly done by the India Meteorological Department, and government has given its mandate to IMD. And IMD is helped by its sister organization, Indian Institute of Tropical Meteorology, National Center for Medium Range Weather Forecast, and its Ministry of Earth Sciences and other sister institutes. But at the same time, these days, you have also some private players in the market, but mainly it is a mandate with the India Meteorological Department, which does it work, and you get the weather forecasts and warnings from time to time of all these areas. And I hope you must be watching IMD weather forecast over television, through newspaper, radio, Facebook, Instagram, WhatsApp, all possible means IMD tries to disseminate the weather warnings to the people. So monitoring and prediction is done by the IMD. That is the second part. But now question comes, if the forecast is generated and it is kept in the computer or it's kept on the register and it's not communicated to the people, it's of no use. So immediately, once you generate the warnings, those warnings should be communicated, disseminated to the people. So third component of the early warning system is communication or dissemination of weather information and warnings. So again, India Meteorological Department, as I told, it sends the warnings to the state government, to the chief secretary of a particular place, district magistrate, to the various authorities, railways, air, if there's airport, all most of the agencies, this weather warnings are issued. Then it is given to the media, print media as well as electronic media. They are also available on the website of India Meteorological Department. Then, as I said, social media is very important these days. Through social media, like right now also through social media, we are engaged. So all these information is put on the social media and it reaches to masses very quickly. So that is the third component of the early warning system. And the fourth component of early warning system is your action or response. So the response here, the role is of the state government once again. The district authority, suppose a cyclone is, or a weather system is going to hit a particular district. And already IMD has issued a weather forecast and warning, location-specific warning for that particular district or taluka. So then the district magistrate authorities should know, suppose if it's a cyclone, so they should immediately vacate the people and put them into shelters, provide them with the medicine, food, etc. And once the cyclone is there, they can stay in the shelter. And after that, once cyclone is over, they can come back to their houses, whatever it is there. So if action is also taken by the respective authorities, then that completes the entire early warning system. That means all these four components had to be in the same frequency. Even if one of them breaks or doesn't work, the entire early warning system will fail. Say, for example, if there is a there is a prediction of a heavy rain, but if it is not communicated, it has no meaning. Right? Early warning without early communication has no meaning. As I told you, if I generate a warning and I keep it in my computer only or in my register, and I don't send it to the people, then it's of no use. Similarly, early warning and early communication without early action has no meaning. Like, for example, in the case of Kedarnath in 2013, where when I was the director of the Meteorological Center of Dehradun in the Uttarakhand state, I had told the government well in advance, 3 to 4 days in advance. That means there will be heavy to very heavy rains, there will be landslides, and we should not allow people to go to the mountains. And if they are in the mountains, they should be shifted to the safer places. And this was a top news in the front page of the newspapers, and it was running in the television everywhere. But state government failed to stop people, failed to move people from the vulnerable areas. And the result was that thousands of people lost their lives, thousands, even wildlife lost their lives, cattle, etc. And it was a big disaster. So this is how, when there is a early warning, early communication, but no early action. So remember here, hazards, which we call it weather hazards, 70 to 80% of the disasters are because of weather phenomena. Weather hazards were there 1,000 years ago also, they are now also, there will be in the future also. And future, it could be little more as well because of climate change. But remember, if you have early warning of these weather hazards, we will stop them. And if people are prepared, we will prevent this hazard getting converted into disaster. We can save the money, we can save the lives, and the money which we have saved with that money will go into other developmental activities, and that will again further give a boost to our economy. So everything is linked. So I think I will stop at this stage and I will take questions, and that will clarify if you have any doubts about it. Thank you. Thank you very much.
Okay, sir.
Yeah, but was it clear? Any confusion?
No, sir. No.
So anybody has a question? I want more questions. People should ask, even if it is a basic question. Don't feel shy. Many times we have confusion, but we don't ask. We are scared to ask questions. Don't be scared. Feel free to ask questions.
So if you have any questions, please raise your questions.
Yeah, raise here. They can write down. And can I see if somebody writes down the question, or maybe they can give it to you. You can pass it on to me, or you can read it down.
Yes, sir. So any questions?
How many participants are there? Hello?
Yes, sir.
How many participants are there?
8.
8 only. Okay, okay.
So some are watching through YouTube, sir.
YouTube. Okay, okay, okay. Fine. But nobody is asking question. That is very strange. That means nobody has understood anything.
No, sir. We got it actually.
You got it?
Yes, sir.
Okay. Fine, 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 fine. Okay. So
I
how
think
much time I
more
have taken? And how much time is any time left?
45 minutes, sir. 43 minutes have taken, sir.
Okay. And still we have more time?
We have 15 minutes more, sir.
Okay. So then I can probably ask the questions. But then I don't know whether somebody, you have very few people online who can answer it.
Yes, sir.
Should I ask the question then? No.
Not like that.
Yeah, but there should be some query, anything related to environment. You people want to know. At least ask them at least to ask one question at least.
Yes.
Some clarification should be there because I don't think I mean all of you know everything about weather and climate.
Yes, we have questions, but I think they feel shy, sir. They feel
But
shy to ask questions.
they're shy to ask. No, no. But then why should they feel shy? They can write it down and read it. Right? Doesn't matter. See, one should not feel shy. Okay, I think that nobody wants to ask question. So shall we call it a day? Shall we end it?
Okay, sir.
Huh?
Okay, okay. That's fine.
Okay, okay then. Thank you very much.
Thank you for your time, sir.
Thank
It's
you.
been a great time. Thank you, sir.
Thank you. I hope you have liked it and you will use this information to, save your life and help the other people also save their lives. And they should start factoring weather and climate information into your day-to-day planning. So tell them to visit Indian Meteorological website, and there are also certain apps by the India Met Department. You can download those apps. It helps you where lightning is going to happen, what are advisories for the farmers, and what is the weather forecast, where is the warnings. All those things will help people become resilient, prepared. And if you are prepared, you can meet any of the extreme events and still be safer. Thank you. Thank you very much for the opportunity.